All right, so if you're diving into the world of data with Python, you've probably heard two names pop up constantly: NumPy and Pandas. In this explainer, we're going to skip the textbook definitions and get right to it, showing you why these two libraries are the absolute bedrock of data analysis and how you can use them to start making sense of all that messy data.
So, picture this. You finally get your hands on some data. Maybe it's a CSV file. Maybe you pulled it from a database. But it's almost never pretty, right? It's got missing values, weird formatting, and there's just a lot of it. This is square one for pretty much every data project, and honestly, it can feel a little bit daunting. So, you might be wondering, why not just use a standard Python loop to go through everything? Well, this slide nails the answer. It's all about speed. That turtle on the left, that's your classic Python for loop, just plodding along, one item at a time. The rocket on the right, that's NumPy. It's doing something called a vectorized operation, where it hits the entire array all at once with one super optimized command. And we're not talking a little bit faster, we're talking orders of magnitude faster. This is the #1 reason the entire data science world is built on this stuff.
Okay, so here's our game plan. We'll kick things off with NumPy, the fast foundation for all things numbers. Then we'll level up to Pandas, which is your go-to toolkit for day-to-day analysis. From there, we'll get our hands dirty with shaping and cleaning data, and then see how to pull out some amazing insights with aggregations. And to wrap it all up, we'll put it all together in a quick, hands-on project.
First up, NumPy. The name literally stands for numerical Python, and it does one thing incredibly well. It gives us a super efficient way to store and work with huge arrays of numbers. Just think of it as the high-performance engine under the hood of pretty much every data science tool you'll ever use.
The absolute heart of NumPy is something called the ND array, or n-dimensional array. Now here's the key difference between this and a regular Python list. A list can hold anything, numbers, strings, you name it. But a NumPy array, it insists on having one single data type. Now that might sound like a drawback, but it's actually its superpower. Because all the data is the same type, NumPy can pack it all together in one continuous block of memory, which makes it incredibly fast to work with.
And if you've ever used a Python list before, this is going to feel like coming home. Getting to your data is super simple. You use square brackets and a number to grab a single element, and you use a colon to slice out a whole chunk of the array. The syntax is clean, simple, and probably already familiar.
And this is where that raw speed we talked about comes from. When you type my_array times 2, you're not telling Python to loop through each number one by one. No way. You're using what's called a universal function, or ufunc for short. This one simple line of code pushes the entire calculation down to super fast, pre-compiled C code, and it applies that multiplication to every single element at the same time. That's the magic trick behind the massive performance boost.
So let's move up a level. If NumPy is the high-performance engine, then Pandas is the whole car. It's actually built right on top of NumPy, and it gives us all the high-level tools we need for wrangling real-world data, especially data that isn't just a perfect grid of numbers.
And this right here, this is the star of the show in Pandas, the data frame. The super-powered spreadsheet analogy is just perfect. It's got rows, it's got columns, just like you'd see in Excel, but you can work with millions of rows just as easily as you can work with 10, all with just a few lines of code.
Let's just break that down for a second. A data frame is the whole two-dimensional table, right? But it's really useful to think of it as a bunch of columns all stuck together. Each one of those individual columns is its own object, called a series. So a data frame is basically just a collection of these series all sharing the same index or row labels.
And maybe the best part? Getting your data into one of these is ridiculously easy. First, you import the library. Everyone calls it PD. Then, you just use a simple function like pd.readcsv and point it at your file. And just like that, it's loaded into a data frame. A quick call to .head, and you can see the first few rows to make sure it all looks good. It's that easy. Okay, so we've got our data loaded. Now for the fun part, or the real part of data analysis. Real-world data is messy, so the next step is always to shape it. Grab the pieces we need, filter out the noise, and figure out what to do with all those blank spots.
Selecting a single column couldn't be easier. You just treat the data frame kind of like a dictionary, using square brackets in the column's name. When you do that, you pull out that entire column as a Pandas series, which you can then work on all by itself.
Filtering rows is where things get really clever. It uses a technique called Boolean masking. See, when you write that df revenue greater than 1,000 part, Pandas first creates a temporary list of true and false values, one for each row. It's true if the revenue is over 1,000, false if it's not. Then, it uses that list, that mask, to show you only the rows that got a true. It's a really powerful way to ask very specific questions of your data.
But what about the gaps? The blank cells. Because let's be real, real-world data is never perfect. Maybe a sensor failed or someone just didn't fill out a form. This is a problem you will run into, and thankfully, Pandas is built to handle it.
You basically have two main paths you can take here. The first is the quick and easy route. Just use drop-NA to get rid of any row that has a missing value. It's fast, but you risk throwing away good data. The second option, which is often better, is to fill in the gaps using fill-NA. You can fill them with a 0 or maybe the average of that column, whatever makes the most sense for your project.
All right, our data is clean, it's in the right shape. Now we get to the really rewarding part, summarizing it. This is where we stop looking at thousands of individual rows and start seeing the big picture, turning all that raw data into a few powerful, meaningful numbers. And Pandas gives you these super simple tools right out of the box. You grab a column and then you can just tack on a method like .sum to get the total, .mean for the average, or .count to see how many sales you had. These simple commands are your bread and butter for analysis.
But the absolute powerhouse of aggregation, the real game changer is the group by method. It follows this beautiful three-step pattern: split, apply, combine. First, it splits your data into smaller groups based on some category, like product type. Then it applies a function to each of those little groups, like summing up the revenue. And finally, it combines all those results back together into a brand new summarized data frame. This one idea is the key to unlocking so many insights.
Okay, theory is one thing, but let's get our hands dirty and see how this all works in the real world. We're going to use everything we just covered to do a quick analysis of a sample sales dataset.
So here's what we're working with. It's pretty straightforward. Each row is a single sale, and we've got the date, the product name, and how much money it brought in. Nice and simple. Perfect for what we need to do.
Our mission is simple. Find our top 5 best-selling products based on total revenue. And check this out. This is where everything we've learned just clicks into place. You can read this single line of code just like a sentence. Take the sales data, group by the product, grab the revenue column, sum it all up, and then give me the .n largest 5. A complete, complex question answered in one clean, elegant line of code.
And that one beautiful line of code, it gives us this. A clear, simple, and immediate answer to our question. Right away, we can see which products are our heavy hitters. We've gone from a messy table of data to a clean, actionable insight in just a handful of steps. So, there you have it. NumPy and Pandas give you the power to wrestle your data into submission and pull out real answers. But an insight isn't very useful if you can't share it with anyone, right? That bar chart is a good start, but what comes next? This leads us perfectly to the next step in any data journey, visualization. How do you turn these numbers and tables into a compelling story? We'll dig into that next time.